Hi, I am Judy Madulara and this is my video presentation for Numerical Method Laboratory Plate number 8, Activity 1 and 2. So for Activity 1, we have this function script file name, which we have the function for L, R, and T, which represents L as left, R as right, T and as trapezoidal. So this function returns the value we obtained from the different numerical approximation using the left endpoint, right endpoint, and the trapezoidal rule. So here we have the x, which is given. This command generates the value of x. Then y is equal to the function of x, which defines the y using the function of x. Then the mid underscore sum. This use this uses the slice and sum to second to nth y entries in ones. So we're going to find the left endpoint and the R endpoint rule using this command L and R, and then the trapezoidal rule using this one, and then N. So to run this, we have this script for activity for plate number 8, activity 1. So we have the preliminaries given, where is the given from the problem, then the format long to change format into long, then this f is defined, is the f function, a is the initial point, b is the last point, and n is defining the n. Then we are going to call the function func underscore plate 81 that we explained last earlier, this one. Then this true value underscore integral, which calculates the percentage with respect to the actual integral true values. And we're going to solve the percentage error on left endpoint rule, this command, and below it is the command for the display of the result of the percentage of L, which is the left. Then another same goes as the left, where you just replace the L with R to present the percent error of R. Then same goes at in trapezoidal rule, where we're just going to replace the R and L used with T to display the percent error of T. So we're going to run this command. I have slow and slow. How we have this result from this script above for the script underscore plate 8 script file. The L is equal to 1.286, etc. The R is equal to 1.22, T is equal to 1.218, and the true interval integral is equal to 1.28. And its percentage error for L is 0.170%, and for the percent error of R is 0.16981%, and for T is 0.00010%. And that would be all for activity number 1. And for activity number 2, we have this script file name plate 82, and we have this function plate 82, the FAN B and N, which computes the midpoint rule approximation for the integral function f and the given intervals a and b and the interval n. So entering the preliminary data, So A is the lower point of the integral. We're going to see this text in the command window, and B as for the upper input, N is for the steps or interval, and delta x is B minus A over N. So to create the vector to hold the values of x based on the delta x using this command, x is equal to the square bracket of A delta B and delta x and the B. And for this one is going to define a vector to hold the values of x based on delta x. So here the x is creating, then f is defining. We have f is equal to x the square d raised to the power of 0.5, and we are going to perform calculation via midpoint rule using this command below. And to display the result, we have this and 2, and we are going to run this script. So here we have they asked for the lower point of integral. So let's say we have 1, then the upper point of integral, which is 2, and here again the MATLAB need the command that we created need the steps, which let's say we have 3, and chadan the n is equal to 3, and the delta x is equal to 0.33, and the approximation of the function is 1.62. So that's all for activity 2. And that's the end of the video presentation for laboratory plate number 8. And I thank you.